When we talk about choropleth maps, which is probably the one you guys will make the most of, whether you're working in the media or you're working in public health, there are a few huge design decisions that I want to talk about before we go any further. So right-click, back into Properties. So why does this map look the way it does? Why are certain areas in Manhattan dark purple? What are the key design decisions here in this choropleth map? Has anybody identified any of them? Let's talk about those default variables that ArcGIS, the Times New Romans of ArcGIS in terms of choropleth mapping. I'll start. One of them is purple, right? What else? So I'm going to choose a different attribute. I have no idea what this is. And what changed? What's changing as I scroll through these attributes?
The range.
The range. Okay. So what do you mean by the range?
Some are expressed in percentage, some are probably absolute values.
Right. And then even if they're all percentages, what am I looking at here? Let's talk about the dark purple symbols on this map here. What separates the dark purple symbols from the second group of purple symbols?
ArcGIS is using some sort of default decision to choose the bin widths or percentages.
Right.
Get a different color.
So, very good. That's exactly right. When we first open this up, this is I always describe it as the Times New Roman of ArcGIS. It's the default setting, but it's not the right setting for almost any map. This is 5 what we call cartographic classes. If you think of them in terms of a histogram, they're 5 bins. And the thresholds between those bins are extremely influential on the appearance of the map. So this is percent with a college degree. The lowest class goes from 0%, which makes sense. I'm fine with the 0% being the lowest threshold. But this arbitrary number here, 12.55, how is that determined?
Statistically from the data set?
Statistically from the data set. So let's come up with a couple alternative ways. How would you classify this data? How would you bin out these block groups in terms of percentage of human beings with a college education?
Depends on the purpose of the map.
It depends on the purpose, but let's say it's for the New York Times. Yeah.
Well, the two most common ways would be to make the intervals equal for all the classes.
Yeah.
And the other way would be to make the number of polygons in each class as equal as possible.
Those are exactly right. The two dominant schools of thought here are, yeah, we can go with 5 classes. If we did this equal interval approach, what would this threshold become? 20. Right? That makes sense. Let's try that. So that is actually called the equal interval approach. So if I go into this classify, if I click on this classify button, and I click on the equal interval selection, what's going to happen to the blue lines in the histogram below? They're going to go from numbers from like 12.55 to 23.71. So that from 12.55 to the 20. So now they're 20, 40, 60, 80. All right? Look how influential this is, though, guys. Before I apply those changes, did everybody see how that changed the map? It's a hugely influential decision on how the actual map is going to look. So the other approach, before we go too far, was to, instead of having equal intervals go 0 to 20, 20 to 40, 40 to 60, instead of doing that, have equal number of block groups, divide the teams up into equal number of players, right? So we have 2,218 block groups in our data set. So the other dominant school of thought is to say, I want to have 5 classes of approximately 453 block groups in each one. That is not called equal interval, that's called quantile. in the parlance of the GIS people. So we keep that the same. We go back to our classify, and I want you to look at how distinct these two maps look. So before I hit OK, everybody look up here. This is equal interval, totally acceptable, justifiable way to classify this data, and quantile. All right, so the first thing you see is a hugely different map, right? So every time you look at a map from here on out, I don't care if you make maps after this, but at least emerge from here as a savvier map reader. When you look at these legends, just know that those arbitrary, seemingly arbitrary decisions of classification are hugely influential on the actual product, the visual artifact in front of you. So the quantile, to me, it makes it look like more people in New York City are educated, right? So if I was trying to persuade the mayor of New York City to give me money to help more people go to college in New York, and I was going to either give them the quantile map or the equal interval map, I will go back to the equal interval. One of them appears to make education in New York look less achieved than others, right? So that is the first major lesson of thematic mapping. In terms of choropleth mapping, is classification. So what do you guys think? We're going to make this together. So do you guys think that we should use equal interval, or should we use quantile? Equal interval. Does everybody agree?
It's understandable.
It's understandable. And it is. And then we'll just go through this for 1 second and we'll move on. But it's understandable because these are nice clean numbers.
Yes.
Okay. Well, let me just, the people who would argue that, let me just, I'm a big fan of quantiles. And I can make them understandable by doing this one thing. So I'm going to go to quantiles and walk you through your argument. This doesn't make any sense now, right? Why would these numbers don't make sense? However, if I change the legend, I can make them make more sense. If I say 0 to 20th percentile, right? Okay, now does that make sense? Probably not to a lay audience, right? But maybe more to a statistical audience. So we'll go back to equal interval.
What was the default classification when you first opened?
What's that?
You had the third classification, which was the default one when you opened?
Yes, the default one, good question, is what ArcGIS calls natural breaks. I think that's the default, right, Jeff? Which is essentially an algorithm that goes through a distribution of data and finds the biggest gaps where there's the least observations in the number line and places thresholds there. And it makes no rhyme or reason to the average person why that is, but it's trying to find natural clusters of observations and group them together and separate them at natural places where there are not numerical observations.
So spatial clusters?
No, not spatial clusters, numerical clusters. So if there's a lot of 9% and not anything until 12%, they'll try to put a class break between 9 and 12. Yeah.
Is there an established ethics, if you will, within the profession? I mean, like, is there something?
No more than there is with writing. And I always compare it to writing. You know, even scientific writing, there's always tone, there's always rhetoric, whether you want it to be or not. And I'm not going to get all postmodern on you, but.
So there's nothing wrong, for example, if you wanted to say, okay, well here's one color for all places where less than half the population have a college education, and then you gradiate beyond that.
Let's do that. So how would I do that? I would do equal interval and choose 2 classes. And if I want to be sensational, I want to make the places where this is less than 50% red, right? Because that's always everybody's favorite sensational color. Oh my God, right? Look at this. So that's a fascinating question. Is there an ethics? No. I mean, no more than there is when we're trained to write for scientific reasons. I just think it's a visual extension of reporting information. So, you know, it's always surprising. I have a map hanging in my house that actually has percentage of Americans in every county in 1960 with a high school education. And the highest class is over 25%. And it's a very small percentage of the counties in the United States, which is shocking to me. We're pretty much at that level with college education now. But it's still really low, especially for the people in computer labs at Harvard, to realize like there's not a lot of people out there who actually have a 4-year degree. So, you know, whatever the purpose of your map, you can make them sort of, I would use the term sensational for a map like this, but sometimes that's the right tone to strike. Generally, for some kind of scientific communication, I would go back to a more nuanced presentation of the data without the giant red splotches. Yeah.
So there's kind of the choice of what you're trying to convey with the map, but are there also practical concerns as far as the numbers of classifications and things that would be visible? Because we could obviously take this to 100 different classifications.
A great question. If you don't mind me stopping you there, let's do that and figure out why, you know, if I go 20 classes here, equal interval 5%, it's great, right? What's wrong with this?
You can't spot the disparities, the differences.
Right, we're talking about those just noticeable differences in terms of human perception. I guarantee if I said, go find me a 35 to 40 block group, go find this swatch of color in that mess. A lot of you would go for the 25 to 30, 30 to 35. A lot of you would not be able to visually discern one class from the next. So as a rule of thumb, between 5 and 9 classes based on the literature, noticeable differences. So I like the number 5 because it's divisible, especially when you're working with percentages, but there is no reason I couldn't use 7 here. Similarly, I can change the color scheme to make those differences more discernible by adding a certain element of hue, but maintaining the sequential idea. So this yellow through green to blue, I can take this higher in terms of number of classes that are still discernible if I add in a secondary hue here through blue or green. In general, 5 to 9 is the short answer to your question. But you'll see people do this all the time. You know, these areas, when you have more classes, you can identify areas where there's very few people with college degrees. Now, a lot of these areas are where nobody lives. I think one of these is the airport. But some of them are actually census tracts where less than 6% of the population has a college degree. So that's a core plus map. And so those are the main decisions. So you have number of classes, how you're breaking up those classifications into groups, numerical groups, which color you're going to employ, which color scheme you're going to employ. So I think we all like the equal interval 5 class. So I'm just going to go back to that with this classify tool. And I'm going to use a nice blue color scheme here and hit OK. So my New York geography is not very good, but it is true that places in Manhattan have the highest education values. Right? You can see Central Park right here where my mouse is. Central Park West and east of the park have a lot of education, right? Who's from New York here? Somebody's from New York, probably. Okay. All right. So, Jeff, let's say I want to make a series of maps. So this is going to be the proxy we have for education. Remember I said we're going to make a map that has education, poverty, and unemployment all in one. We're going to make a layout. So the next map